Okay, we're back at it. Problem number 27. What is the solution set of the following system of equations? Well, I looked at the answers. The answers are not written with set notation, so I think they're just asking you for the ordered pair. In this case, the problem is so nicely set up to use the linear combination method, or sometimes it's called the addition method, where the x's are lined up, the y's are lined up, the equal signs are lined up, the constants are lined up. And not only that, the y's have opposite signs. This is plus 1y, this is minus 1y. If you use this method here and add straight down, add the left sides, add the right sides, the y's are going to cancel. I'm going to get 2x equals 10. Divide by 2, I have x is equal to 5. My answer is 5 comma something. Now, since it's multiple choice, you can always check your answers to see if only one of the answers has a 5 for the x value. Then you could take the answer and you could say, okay, let me check this, let me plug in. In fact, if you forget, remember on a lot of multiple choice problems, if you forget exactly how to approach it, my suggestion is work backward from the answers. Okay, if it's a multiple choice test, you can work backward from the answers and maybe you can logic it out, or maybe you can eliminate a couple of obviously wrong answers and then make an educated guess. But by all means, if you forget something, don't just skip the problem. Just don't say, well, I haven't had a C in a while, and mark that one down, although I've done that before. Make sure that you try to work backward from these. I should have mentioned this in the very first video, but I want to make mention of it now. It's a multiple choice test. Work backward from the answers if all else fails. Because I can work this problem by taking each answer and substituting in for x and y until I get the one that satisfies both equations. I'm not going to do that, but I could work that problem that way. And as I look at the answers here, I have it written down on this piece of paper, it does look like only one answer has a 5 there. Now, I would go ahead and solve it just in case it didn't, but if I plug the 5 back into either one of these for the x, I'll take the top one because I'm shying away from the minus sign there. I would have 5 plus y equals 7. Y is equal to 2. Right there it is, and there's my solution set right there. It would be answer B, I believe here. Okay, use the addition method when they're lined up so nicely. Now on this problem, it's the same kind of a problem. What's the solution for this system of equations? But notice that the x's and the y's aren't lined up nicely. However, also notice that the bottom equation has one of the variables isolated to one side. I would use substitution here. I would plug this expression in, what y is equal to in the bottom equation, in for y in the top. You best be careful of that minus sign now, because this is x minus. I'm plugging all of this in for y, so put parentheses, and then that equals 2. And see how you've eliminated one of the variables by making this substitution. Just like I eliminated the y's here by adding the sides together. That's the key. Take a 2 by 2 system down to a 1 by 1 system, which means one equation, one variable. And that's what I have here. Now this is the reason why I put those parentheses, because I am subtracting both, which is like multiplying through by -1. And see how that sign changes? I'll get so many people that'll forget that. And they'll put a -4 here. So now I can combine like terms. I can subtract 4. I get the opposite of x is equal to -2, which means x is equal to +2. My answer is 2 comma something. Now I go back and I look at my answers here, and I'm looking at my choices, and I'm noticing here that only one of them, let's see, yeah, it looks like only the second answer, answer B there, has a 2 for the x value. So right away, I don't, especially if I'm hurting for time, I can feel pretty comfortable with putting that answer in. But I'll go ahead and plug it in just for the heck of it, and I'm going to plug it back into the equation that I used for the substitution. Put the 2 right in there. Y equal, because the y is already by itself, y equals 2 times 2 minus 4. 4 minus 4 is 0. And that is answer B. Alright, this is pretty straightforward for substitution. This is pretty straightforward for the elimination method, or the linear combination method, or the addition method, whatever your teacher wants to call it, or your textbook wants to call it. Now we get to some serious stuff here, because now we're going to have some story problems that are going to give us systems, and then we're going to look at a 3 by 3 system, 3 equations with 3 variables. First things first, the cellular telephone company has 2 plans. Plan A charges $11 a month for the plan, and then 21 cents a minute while you're on the phone. Plan B charges $20 a month. That's a lot more per month, but charges less per minute. It charges only 10 cents a minute. After how much time to the nearest minute will the cost of Plan A be to equal the cost of Plan B? So I want to figure out Plan A, and I want to figure out Plan B here, and then I'm going to set them equal to one another. Well, I can probably do this with only one variable because of the way this problem is set up. I think I'm going to definitely use two variables on this problem number 30, but I'm going to let x be the number of minutes that you're on the phone. Okay? So for Plan A, it's $11 a month plus 21 cents times the number of minutes. For Plan B, it's $20 a month plus 10 cents. Here, I'll go ahead and put the 0 there. 10 cents for each minute. And I want to know when these two things are equal. All right, so I want to know when 11 plus 21 cents times x is equal to 20 plus 10 cents times x. Of course, I'm not going to put the dollar sign in there. Now, I would suggest just leave it as is. These are not tough numbers, and it's a simple enough equation if you go ahead and multiply through by 100 to eliminate the decimals, which I really like to do. I like to get rid of decimals and fractions in my equation when it's necessary. I think you're probably putting yourself in a position where you might mess up and make a silly arithmetic error here. But I am going to go ahead and get the variable on one side. I'm going to subtract 0.10x from both sides. Now be careful, you're subtracting decimals, so line up the decimal point here. And I get 11 plus, this is going to be 0.11x is equal to 20. Alright, then I am going to subtract 11 from both sides. And I get 0.11x is equal to 9. Now, if you just can't stand that decimal anymore, go ahead and slide the decimal, write this as 11x, write this as 900. But I'm going to divide both sides by 0.11. Now, you'll have a calculator close by, I would imagine. I'm going to go ahead and do the division here. Take it out 3, 2, and 2. Oop, 2. Decimal point goes right there. 11 doesn't go into 9, it goes into 98 times. 8 times 11 is 88. Subtract 2, bring that to 0, goes in 1 time. 11, subtract, that's a 90. It's going to be repeating. 81, 81, 81. So we are rounding to the nearest minute. So this is 81.8 minutes, so we're looking at 82. So this is going to be 82 minutes. Is that a choice? I don't even know if I wrote down the choice. Let's see. Oh, look at this. The choices are not written as just 82 minutes. They have converted this into hours and minutes. Now it says how much time to the nearest minute, so it doesn't say how many minutes, it just says how much time. So we know 1 hour is 60 minutes, so that's 1 hour, and then 22 minutes left over. Now let's see if we match an answer. Looks like answer A. Alright, neat problem, like that one. I'm glad I left myself some space. Hopefully I can squeeze this one in here, and then I got to do this guy. I might have to erase a little bit of this, so make sure that you're seeing this as we go over to problem number 30. Jack bought 3 slices of cheese pizza and 4 slices of mushroom pizza for a total cost $12.50. Grace bought 3 slices of cheese pizza and 2 slices of mushroom pizza for a total cost of $8.50. What is the cost of 1 slice of mushroom pizza? I don't know how much a slice of cheese pizza is. I don't know how much a slice of mushroom pizza is. I'm going to let X be the cost of a slice of cheese pizza. Now I'm going to go ahead and write this out because when I'm dealing with 2 variables, 2 unknowns, I don't want to lose track. I want to make sure I know which one is which. If X is the cost of a slice of cheese pizza, then the cost of a slice of mushroom pizza would be Y. And this is the cost for 1 slice. It might be $1, it might be $1.50, I don't know. But we know that 3 slices of cheese pizza at X a slice, that would be 3X, and 4 slices of mushroom pizza at Y dollars or whatever that is, a slice, that would be 4Y. That combined, it cost Jack $12.50. Whereas Grace here bought 3 slices of cheese pizza, that's 3 times X, Did I get that right? Is it 3 for both of them? I hope when I printed it out, it came out small. We'll find out here in a second. 3 slices and then 2 slices of mushroom pizza. So that'd be 2 times y is equal to $8.50. Now, I didn't even look at this problem originally. If the pizza for the cheese is the same, then we just look at the fact that Jack paid what, an extra $4 for an extra 2 slices of mushroom pizza? And it's looking like $2 for a slice of mushroom pizza. Now, if you didn't notice it, like I didn't notice it, then you're going to probably want to use the elimination method, but it's not set up quite right because these are not opposites. I mean, I've got the same coefficient. If I multiply the bottom one through by -1, and then add, I get 2y is equal to 4, y is equal to 2. And y is what I want because it says what's the cost of 1 slice of mushroom pizza. So that would cost $2 for 1 slice of mushroom pizza, and hopefully that's a choice. It is. It's answer B. Oh, that was a nifty little problem. We could have saved ourselves a little aggravation if we just used a little common sense and read it closely. Jack bought 3 slices here for Grace. That evens out. That kind of cancels one another out. So the difference in price is the difference in the number of slices of pizza, mushroom pizza. An extra 2 slices for an extra $4, $2 a slice. All right, now we get a real system here. This is a 3x3 system. And to solve a 3x3 system, you got to make a plan. Okay, now again, it's multiple choice. I don't have all the multiple choice answers written down, but if you just like, I'm not sure how to do this, or I'm getting fractions and it's all messed up, take each answer one at a time. It's going to take a little bit of work, so hopefully you've got your time budgeted well, and substitute in for x, y, and z, in this case x and z, and x, y, and z, and see which one satisfies or makes all 3 equations true. That's the guy. That's the one you want. So what I'm suggesting is that if you're hurting for time, or if you're working this one out, and you're just not getting anywhere close to it, you can't seem to get there, work backward. But I'm going to show you how you can do this one. Now, what I like about this problem is that the middle equation doesn't have the variable y. If I take the other 2 equations and eliminate the variable y, then what I've got working here is a 2x2 system. I'll have another equation with just x and z to go along with this guy. Then I can solve the 2x2 system like I've been doing over here. So what I'm going to do here is I am going to leave the bottom equation the same because it's got a minus 4y, but I'm going to multiply this one through by 2 to get a plus 4y, so I can get those y's to cancel. Ignore the middle guy for just a second. So if I multiply the top one through by 2, I get 2x plus 4y minus 2z equals 10. Don't forget, you have to multiply every term on both sides by that constant, by 2 in this case. So many people forget to multiply the right side by the 2. They leave a 5 there, and it goes to heck in a handbag. All right, now the bottom one I'm going to leave the same because I've already got the minus 4y, which is exactly what I wanted. And I'm going to leave him exactly the same. I don't have to multiply through by anything there. Now, when I add the left sides, add the right sides, these cancel. So I end up with 5x minus 4z is equal to 17. Now, I've already got this guy here. He only has the same 2 equations that this guy has. So I'm going to kind of set this one up using the elimination again. But I'm seeing right now, those aren't going to cancel, and those aren't going to cancel. But if the sign is different like this, and this is 1, I can make him anything by multiplying. If I can make him a positive 4z to get rid of this negative 4z. I'm going to take this guy right here, and I'm going to multiply him by 4. I get 8x plus 4z is equal to, don't forget the last one, negative 4. 13x, these cancel, equals 13. Oh, you gotta feel good when you get an integer for the first one. So I get, divide by 13, I get x is 1. Now again, I can kind of look back here and, oh, in fact, if I read the problem, that's what I'm solving for. I'm solving for x. I don't even have to find the other 2 guys. Wow, what a time saver this is. However, it looks like I didn't match one of the answers, so I gotta think that I wrote it down wrong. Again, I've done this about 3 times now. Well, I didn't write it down wrong. So either I wrote the answers down wrong or I couldn't read the original problem there. It looks like x plus 2y minus z is 5. It looks like 2x plus z is negative 1. It looks like 3x minus 4y. Oh, I don't know. Is that a minus or a plus 2z? Well, I will have to maybe make an addendum to this particular video when I can make sure I've got the problem written down correctly. I thought I had it written down. Let's see. Well, did I make a silly mistake? Let's go back. I took this one, I multiplied through by 2. That looks correct. I left this guy the same. I added down, that's 5, that's minus 4, that's 17. I brought this guy over after I multiplied through by 4. Oh, I gotta think I'm doing them right. Maybe I'm not solving for z. Maybe it's not an x that I'm solving for. Let me finish this problem off. Let's see what happens. Now that I know what x is, I can go back, let's say, to this equation, and 2 times x, which is 1, plus z is equal to negative 1. So I have 2 plus z is equal to negative 1. I have z is equal to negative 3. Now that's a choice. That's answer A, but I can't tell from my copy if I'm solving for z. If I'm solving for z, I'm done. It would be answer A. Well, we'll find out. Let me go ahead and find y now. Don't ask me why. Okay, so I take this top one, I plug in 1 for x, and I plug in negative 3 for z, so this would be minus negative 3 is plus 3. So I have 2y plus 4 equals 5. I have 2y equals 1. I have y as a half. I mean, my answer is 1/1/2 negative 3, but perhaps they're asking for you to find z. That would make the most sense here, and if that's the case, then it is answer A. I'll be interested to find out how this one turns out. Hopefully I haven't led you astray. All right, another video coming.